you like separate, integrate, differentiate, and then precisionate?
Why would you differentiate?
Differentiate your first C and your second C, and it changes.
I don't think so.
But it sounds cool.
Yeah, it's another 8 in there, but let's stick with separate, integrate, use your initial condition to solve for C to get the specific solution. And again, what makes the problems hard is we can make any one of those steps difficult. We can make it tricky to separate. We can make the integration tricky if it is U substitution, or if it's trig, or if it's trig and U substitution. We can make solving for C kind of a pain on the last step. And if we're really feeling mean, we can turn up the dials on all of them, make it really hard.
No need for that.
So yeah, we don't usually do that. We usually try to isolate the difficulty maker and make you work hard ones, but not all of them hard. Today, I think we're going to focus on. It's going to be the tricky part is the using that initial condition. And I guess the last step is solve for y, and it's sort of the. Sometimes that's easy, sometimes it's built in. Anyway, let's do number 2. Find the particular solution of dy dx equals negative 2xy through the point 0, 5. Okay, so separate, then we'll integrate, and then we'll use this point to find the specific solution. So move the dx over. When I move the y over, how do I move the y over? How does it get to the left-hand side? Divide. So dy over y on one side, negative 2x dx on the other side. And I should probably start on the far left side of this. Just because there's going to be some extra stuff in there. All right, so integrate both sides. On the right-hand side, I'm going to mention this earlier. Like, if you want to put the integral after the constant, that's fine. If you want to put it in front and then slide it out, that's fine. It doesn't matter. I'm just in the habit of putting it out front of both sides. But if you recognize that negative 2 is just going to slide out anyway, then you can do that kind of on the fly. Okay, so that's the separate part and the start of the integration. The integral of dy over y. Anyone? Natural log of y. So again, you just have to know all those rules. Natural log of y plus c, but again, we're going to do the plus c on the other side. Equals. Power rule is the easy one. Increase the power by 1, divide by the new power, plus c. So natural log of y equals negative x squared plus c. Okay. So we can use the initial condition first, or we can solve for y first.
Initial condition.
So we have been using the initial condition first.
But we're going to solve for y.
Yeah, like start to plug it in on this one, and it doesn't give you nice numbers. So if I plug in 5 for y, I get natural log of 5. I don't want to mess with natural log of 5. So let's hold off on the initial condition. Let's solve for y, and maybe it'll be easier later. Hint, it will be easier later. So on the ones up till now, it was pretty easy to solve for c at this point. Here, c is going to be ugly. Well, it's going to be natural log of 5, and I don't want to deal with that.
Yeah.
So let's solve for y. Now, how in the world do we solve for y?
Raise it to the power of e.
Yep. We're going to raise both sides to the power of e. The right-hand side is going to look kind of weird, but the left-hand side is nice. E to the natural log, that's what cancels each other out. So y equals e to the negative x squared plus c. good up to here?
Yeah.
Because the next step is the wait, what just happened step. Sorry if you think that we've already hit that step. The next step is the what's going on here step. Let's back up for a second. So you don't have to write this down. If I have x squared times x cubed, what is that?
That's x to the fifth.
X to the fifth.
Yeah.
So if I had x to the 2 plus a, how could I rewrite that? We almost never rewrite it this way.
2 times x to the a.
X to the 2 times x to the a. You would never, almost never go that direction with it. Are you okay with this? Some of you are like still looking at me like, what? When you're multiplying with exponents, you add their exponents. If you've got exponents that are added, that means you multiplied.
Yeah, that makes sense.
Yeah.
We got that. Let's pause right here for a minute. Are we okay with this?
That's algebra, yeah, that works.
Some no, some yes. Yeah, you're definitely okay with that step, right?
Yes.
Brooke, yes, you good with that, right? Let's give you a one-way ticket to Algebra 1 if you're not okay with that. All right, so we're fine there. Now let's use that same power in reverse. So I've got x to the 2 plus a. Well, where did that come from? It meant if we added the exponents, that means we multiplied x squared and x to the a. So that means this could be written as e to the negative x squared times e to the c. It's easy to, I think it's easy to see if you can go that way with it.
Oh, you're just doing an example.
Yes, that was.
You were like, where did those numbers?
That's just illustrating the property with easier numbers than e's. Sorry. Yeah,
That's
like
why
where
he
did
was
the,
freaking out.
Where did the 2 and the 5 and the a come from?
So the c is in the exponent. It's not like separated from all that.
This c is in the exponent. Yes, this c is in the exponent. Maybe that helps. Yes, that c is in the exponent, which means we could rewrite it as times e to the c. Okay, back up, big picture. What does c represent at this point?
Constant.
Yeah, just some number constant. So here's another trickery here.
Uh-oh.
E to the, so if c is just some number, then e to the c is
Some number.
just some number. So I'm going to
I
use
don't like that.
I'm going to use a different c and just make it a coefficient. E to the c is a coefficient. This is magic today.
I feel like we're just making our own rules.
I know it feels that way. That's what it looks like on your faces as well. Like,
We're scared.
It's a, why can that be a coefficient? Because that's just c, so it's saying like e times
so
c.
this is a different c. So this is again that c1, c2 stuff.
Yeah. So we should add the differentiate step.
If you want to. If that helps, then by all means, because e to the c is not equal to c unless c is anything you want it to be. So that is the key step with these natural log problems is, well, right in here, this changing the plus c to a c out front. It's like, wait a minute, what magic is happening in here?
Well, we got this.
All right, well, now we've solved for c. Let's now use the 0, 5. This is going to be easier now. 5 goes in for y. 0 goes in for x. And now we sort of get the benefit of all the work we did with the c stuff. Because what's e to the 0? 1. So what's c equal to? 5. So y equals 5 e to the negative x squared.
I like that.
So there's some craziness going on in there. When you e to both sides, that plus c can become a c coefficient, which is good. It's very good. This one would actually not be too difficult to check.
Yeah, but do you
I'm not
want
going to, but that negative 2x would be the chain rule of what's already there. So I think I can see where that makes sense. All right, number 5. Well, is there any question on that other than that was awful? Where did that happen? And any question that you're able to articulate?
Yeah, that's
I mean, you don't really want the answer to why, but the answer to why is coming up, since you asked. On growth and decay, when we get back, these are very much real-world problems on exponential growth and decay. So, yes, there is a why.
Okay, so another question. So we're supposed to come back from February break and remember those steps.
Well, if you look when we come back from February break, we have a block day review and a Friday review.
And we're gonna go over this stuff again.
So we'll go over it again. Yes. Number 5. Find the particular solution of y prime. I'm going to rewrite that as dy dx to help me separate equals 3y plus 6, given that y of 0 equals 7 is on the solution curve. Okay, this one's a little bit tricky on the separate front. Separate, then integrate. So you want to get the y stuff to the other side, but subtracting it isn't really an option. Because if you subtract it, I mean, like algebraically it's an option, it just doesn't do anything for us. Don't write this down. Well, that's not wrong, but it's not helpful, because then I'd have to multiply through by dx, and I'd have something weird going on that 3y term. So you can't just subtract the 3y over.
I wish.
Maybe it would be easier if we fixed the dx first. Let's multiply by dx. Maybe that'll help guide our path here. Any idea on what we do next to get all the y stuff by itself? We've got 3y plus 6 times the x. So how do I undo multiplication? Divide. So let's do dy over 3y plus 6 equals dx. So now we're separated. I'm going to integrate. If it helps to rewrite things so that it looks better, you can do that. If you want to make that 1 dx to help integrate, that's fine. How about the integral of the left-hand side? To use substitution that. U equals 3y plus 6. So du equals 3 dy. So I need a 3 and a 1/3. And the integral of du over u, natural log of u. This time I'm going to remember to put it back in there, 3y plus 6. It is supposed to be the absolute value that almost never matters. It usually takes care of itself. But technically, it's supposed to be absolute value of u equals, again, there's sort of a plus c there, but we'll let the other side catch the plus c. What's the antiderivative of 1? X plus c. What do you want to do next? I don't want to plug in 0 and try to get 7 because I'm going to get a weird. Let's hold off on that. Let's solve for y first.
E to raise e to it?
Not yet.
No? Okay.
I mean, I'll do that eventually.
Multiply by 3?
Let's multiply by 3. Get rid of that 1/3. I don't like the 1/3 either. So natural log 3y plus 6 equals, what's going to be on the other side? 3x plus c. That's a different c now, if that bothers you. Right, it's like, oh, you didn't distribute. Like, I did, but 3c and c are the same thing, if c is anything. So differentiate them if you want to. I mean, not take their derivative, differentiate. Mark them differently if it helps. Now let's do the e thing to get, or at least to start to get y by itself. So 3y plus 6 equals e to the 3x plus c. So how can I rewrite, here's the magic trick.
C e to the 3x.
Yeah, that plus c means times e to the c, means why don't I just stick a c out front? And again, that's a different c altogether there. So if you want to go back and rename your c's, that's fine. If you just want to not worry about it, also fine. This looks like an easy, like you can solve for c anytime you want. It's just this, once you solve for it, you have to keep up with it. You can't start doing these tricks where it's like, oh, it's still c. Like, no, you got to be more careful once you know what c is. So we can solve this for y, or we can find c.
I say we.
Do you want to solve for y? It doesn't matter. It's going to come out the same way either way. Preference, solve for y or solve for c?
For c.
Okay, c it is. So we'll use 0, 7. So 3 times 7 plus 6 equals c times e to the 0. It's convenient when they throw in a zeros in there. So 21 plus 6 equals c. So 27. So I'm going to go back up to this spot. 3y plus 6 equals 27 e to the 3x. Now I'm solving for y. 3y equals 27 e to the 3x minus 6. Divide everybody by 3. 9 e to the 3x minus 2. Let's see. I'm going to check 0, 7 because that's an easy check. I plug in 0, 9 minus 2 is 7, so feel good about that. Solving this one wouldn't be awful. I don't really want to, but it wouldn't be terrible to check it into that one. Okay, so today's assignment is 5 through 9, but we have some time left. So why don't you see how far you can get on number 5, and then I'll work number 5. Actually, I'll try to trail you on number 5. So separate first, and then I'll separate, and then we'll integrate, and then we'll kind of go back and forth. You try the separate step on number 5. Okay, there's the separate step. Move the y over by dividing, move the dx over by multiplying. Now you got your y stuff on one side, your x stuff on the other side. Now it's time to integrate. Integrate both sides. Natural log of y equals x to the 4th plus c.
Yep.
Again, now we have a c, so now it's like, well, when do I want to solve for c? And the answer is probably not now, because I don't want to take the natural log of 7. 0, 7. So yeah, we'll hold off on finding c just yet. So we do e to both sides. So that gives me y equals e to the x to the 4th plus c. And then the magic trick, that e to the c becomes a different c out front. And now we're home free. Now I can plug in 0, 7 and 7 in for y, 0 in for x. And it's nice when they give you a 0 in there, because that makes finding c easy. So y equals 7e x to the 4th. That's another one that wouldn't be terrible to check, because dy dx would be pretty straightforward.
Yeah.
In fact, the 4x cubed, that's the chain rule off of the x to the 4th. So it's not a full check, but it's like, I feel good about it anyway. Number 6. Which of the following is an equation of the curve that passes through the point 1, 1 and whose slope is y squared over x cubed? What the heck is the slope is y squared over x cubed? Yeah, that's just another way of saying slope. So dy dx equals y squared over x cubed. And this one would have been a lot easier if it was the other way around, right? Because
You could take the time and do every other one?
so you could, yeah, you could take the derivative of each of these,
But that's quotient rule.
and then that would be a real mess for like b and d, and even a would be quotient rule. So yeah, let's don't do that. Let's just do it the real way here. So 1 over y squared dy equals 1 over x cubed dx, which I don't really integrate those because I want them as powers. Y to the negative 2 dy, x to the negative 3 dx. Then we can integrate. So increase the power by 1. Be careful. Increase the power by 1. Increase the power by 1.
That always hurts my head.
Yeah, and then now I've got some algebra tricks I need to play. At some point I need to solve for y. But I think I'm going to multiply through by negative 1 to start with. 1 over y equals 1 over 2x squared plus c. That's a different c now, but until I find c, I can just keep calling it c.
Well, different C's.
Yes, it's a different C.
You always thought there's
Do you want to solve for C now or solve for Y now?
Wait, why is that even C?
Uh-oh, what day? I multiplied through by -1. So it changed the sign of C, but since C is anything, it doesn't really matter yet. Until we figure out the specific value of C, we can mess with C and not mess with C, I guess. I'm thinking this looks like an easy spot to solve for C.
Yeah.
So it's just 1, 1. Let's plug in 1, 1, and then we'll have to be careful with the algebra after that. So C equals 1/2. So 1 over y equals 1 over 2x squared plus 1/2. Oh, now this is just an algebra problem. And I see where they got answer choice C from.
People just.
You can't flip the pieces though,
Sure you can.
right? Just flip them all and get C. Like, no, don't do that. C's out. Actually, I don't know where this cube root thing is coming from, so I'm pretty sure B and D are out. So it's got to be A. Now, how would we get there?
I don't know.
If I want to change 1 over y, I'd rather just flip both sides. But if I want to flip both sides,
You have to do that.
I need to get a common denominator, so it's fraction equals fraction. So that's x squared plus 1 over 2x squared. And now I see where answer choice A comes from. If I flip it over, I get 2x squared over x squared plus 1. That's a lot of algebra in that one. Why don't you try number 7? There's an extra step at the end to number 7. Everything works the same, and then they want you to do this end step. Try number 7. So there's the full solution to number 7 for those watching at home.